So dear students, this is the question for today's lecture video, and in this question we are basically asked to calculate the force that is produced by these two charged particles at this charge Q3. So the question says that basically these three charges are positive, having magnitude same, that is 2 coulomb magnitude, and we have to calculate the force that is produced by charge Q1 and Q2 on charge Q3. So students, first what we need to do is we need to find out that what force Q1 is applying on Q3. So since these both are positively charged particles, they both will repel each other, means this Q1 will drag Q3 away from it. So if this Q1 will drag Q3 away from it, its direction will be like this. Let's call this force F13, which charge 1 is applying on charge 3. Similarly, for charge Q2, since these are also positive charges, so this charge Q2 will repel charge Q3 away from it. So the direction of the force that charge Q2 will apply on charge Q3 will be like this. So let's call this force F23. So now students, let's not forget that basically these are electrostatic forces, so they will obey Coulomb's law. And what we know that what is Coulomb's law? Coulomb's law is F equals to K Q1 Q2 over R square, where K is the constant, Q1 and Q2 are the charges, and R square is the distance between the charges. So if I apply this equation on charge Q1 and Q3, it will be F13 equals to K Q1 Q3 over R square. Now see students, in the question we are given that the distance between the charges is 1 meter. See, here it is given. We have an equilateral triangle, each of whose sides are 1 meter in length. So this is 1 meter, this is also 1 meter, and this is also 1 meter. So the distance between charge Q1 and Q3 is 1 meter, and the square of 1 is also 1. So let's simplify it as KQ1 Q3. Okay students. Now for charge, or I can say for force 2 3, I can write K Q2 Q3 over R square. Now the distance between charge Q2 and Q3 is also 1, and the square of 1 is again 1. So let's simplify it and write K Q2 and Q3 only. So now students, our next task is to split force F13 and force F23 into its components. So when I will split, I will get X component here and Y component here, like this, according to head and tail rule. Similarly, for force F23, I will get X component like this here and Y component like this here. So now students, we need to find out what is the angle right here. So we are not given any information regarding angle, but we are given that it's an equilateral triangle, means the angle here is 60 degree if it's an equilateral triangle. So if the angle right here is 60 degree, then the angle right here is also 60 degree according to geometry. So means this angle right here is 60, and similarly this angle right here will also be 60 degree. Now one more thing, students, see, the magnitude of the charges are same, and the force, or we can say the X components, are in opposite direction. So these X components will cancel out each other. So we don't need to work on the X component of these both forces. We only need to work on the Y component, because X component will cancel out each other because their directions are opposite. So we are only left with the Y component of both forces. So if I find out what is the Y component of this force, it will be F13, and since this side is opposite to the angle, so it is sine 60 degree. Similarly for this, it will be F23, and since it is again opposite, so it will be sine 60 degree. So this is the total force that charge Q1 and Q2 are applying on charge Q3. So collectively, I can say that the total force on charge Q3, I can say summation of F is equals to F13 sine 60 degree plus F23 sine 60 degree. Now put the value of F13 and F23 in this equation from this equation. So we can say K Q1, Q3 instead of F13 and sine 60 as it is. Then plus sign as it is. Then instead of F23, I can write K Q2 Q3 sine 60 degree as it is. Now students, focus that charge Q1, charge Q2 and Q3 all have same magnitude. So I can collectively call them Q. Means Q1 is equals to Q2 is equals to Q3, and I can collectively call them Q. So the equation will become K. Q into Q is square sine 60 degree plus K. Q into Q is Q square sine 60 degree. So now these are the two like terms, we can add them, so it will be 2kq square sine 60 degree. Now we know that write 2kq square as it is. We know that sine 60 is basically root 3 over 2, so write root 3 over 2 instead of sine 16, and now this 2 will cancel out this 2 and we are left with only kq square root 3. Now we have all the known values. K is a constant. We are given the magnitude of the charge. We only need to put these values in standard units and find out the answer. So we know that K is basically 8.99 exponent 9. Q is given to us in the question, that is 2 coulomb. So 2 and then a square and root 3 as it is. So now when you will plug in all these values in your calculator very carefully, you will get 6.23 exponent 10 Newton, which means that the total force that charge Q1 and Q2 collectively applying on charge Q3 is 6.23 exponent 10 Newton. So I hope students you have got the question very clearly. If you have any query, you can ask me in the comment section. Plus, if you are new on my channel, don't forget to subscribe the channel, and if you found this video helpful, share with your friends.